Well, good afternoon, good morning, or good evening, depending upon where you are in this world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have, as always, a great webinar on tap with some really great information, but before we get started, we do have a few housekeeping items to go over. First of all, today's event is being recorded, so if you missed any or all of the event, just know you'll be able to access it on demand. We'll be sending out a link after the webinar that will take you to the webinar on demand. And we're also taking questions from the audience. So if you have a question at any time during the event, just use your GoToWebinar control panel and submit your questions. And we'll take a few minutes before the end of the webinar and go over those questions. Okay, with that, we'll jump right on into today's webinar, which is why should I use a time series database? Why indeed? Our speaker today is Katie Farmer, who is in developer relations at Influx DB. Hi, Katie. How are you? Thanks for joining me.
Thanks for joining me.
And okay, great. Well, I'm going to go ahead and just mute myself and let you get right into your presentation.
Great. Thanks a lot. I'm happy to be here. And we're not going to waste a lot of time because I like to spend as much time as possible talking about databases. So first of all, a little bit about me. As mentioned, I'm Katie. I'm a developer advocate at Influx DB. We'll talk a little bit about what Influx does, but more importantly, what you need to know about me is that I never get tired of talking about databases, even though other people get tired of me talking about databases. And so today we're going to talk a little bit about why you might want to use one and what some of the use cases are. But I found that when I start having this conversation, we have to address one question first, which is, what is time series data? So when I think about time series data, I think weather data is the best example, although it's not always the most interesting. Time series data has characteristics that are really unique. It has incredibly high volume, sometimes in the millions or billions of points. It has a natural time order, which means that time is always one of the axes that you would measure for this data. And it's also data where the value is increased by the timestamp. So if you think about it being 62 degrees in San Francisco, that's a little abstract unless you know that it was 62 degrees in San Francisco on a Tuesday at 1 p.m. So we're talking about a level of specificity that you don't often see in other types of data. And also, one of the most important things to me about time series data is that it's more valuable as a whole data set than as individual points, because we learn from the data set. One point, especially when we're talking about millions or billions, right, of points, is an interesting snapshot, but it doesn't tell us that much about the whole data set. More importantly, if we were gathering this data and we lost a point, which happens sometimes, our data set would still be intact. All of the patterns that we care about would be unaffected by losing one point because we have so many to sort of create patterns and curves for us to learn from. So if we lost the one point that said it was 62 degrees on Tuesday in San Francisco at 1 p.m., then we, as you can see from this sort of little graph on the right, we could still follow the slope and figure out what temperature it was and about what time it happened. So let's talk a little bit about what is and is not time series data. On the left, you'll see what is more relational data, which is what we see a lot in more traditional databases, right? Like Postgres or MySQL, things like that. One axis is cake, and the other axis is my mood. These things have a relationship. Now, sometimes they go up together, sometimes they go down. My cake relationship is complicated, but as you can see, time is really not a factor on this version. But if we look over on the right-hand side, this is a time series graph. Now, one axis is always going to be time, And in this case, the other axis is cake consumption events. So we can learn some interesting things. On the relational side, we kind of learned a correlation, right? My mood and cake have some correlations maybe we could learn from. On the time series side, we can look at these data points and ask some questions of our systems. So for instance, between about 9 a.m. and 1 p.m., there's an abnormally high number of cake consumption events. Now, this might lead you to ask some questions about, in this case, me, I'm the system, right? You would ask, well, why is Katie eating so much cake during this time? Like, is there something happening? Is she sad or is she happy? Is she celebrating? So think of this in the context of your, let's say your servers, right? If you saw unnaturally high traffic in this short period of time, you would be led to ask questions about, did you just release some kind of like marketing blast? Did you have a sale? Or, whatever it is that brings people to your site, you can now say, oh, we're having this like spike, or maybe something's going wrong, right? Maybe there's a spike in CPU usage because hardware is about to go out or something. So you can start to see that time gives us this window in which to investigate. It doesn't really tell us anything about the relationship between, right, cake and the time that it happened. But given that window of time, we know the pattern of those events. Now we'll talk a little bit more about sort of how that is useful to you. But getting back to the topic of the day, why do we use time series databases? This is a question that we get a lot. And honestly, it's a question that I asked a lot when I first started working with time series, because lots of people can and do use relational or document databases for this kind of data. So we're going to talk a little bit about the three things that I think are the differentiators, which are scalability, usability, and specialty. So we're starting with scalability. Now, scale can mean a lot of things. You probably hear people saying things like, but does it scale? And honestly, this is one of my least favorite questions, because scale how, right? Like, a lot of people say scale, but not that many people have a specific meaning in mind. Does it scale horizontally, vertically, scale in complexity? There are all these different dimensions with which we can think about scale. So for me, I like to think about it in terms of IoT. You'll see from my beautiful graphic here that I have a drone, and this drone is called the Skynosaur 2000. Now, a Skynosaur 2000 drone sends data back to the database about every 5 seconds. It's gathering data more often than that. It sends them in batches every 5 seconds. Now imagine that my drone is flying for 1,500 hours. Now, coincidentally, that's the amount of time that the Skynosaur would need to fly to get its pilot's license. That's why it's a pilot now. In those 1,500 hours of flight time, my drone by itself would be sending over 1 million data points. Now imagine that you are the makers of this Skynosaur drone. You are Skynosaurus Rex Incorporated. You don't have just one device, right? You might have thousands or more, and they could all be phoning home, sending in these millions of points. So we start to see that in this case, when we talk about scale, we really need a database that specializes in higher rates with eventual consistency, even across distributed systems, right? And that's something that time series does really well. Time series databases are optimized for higher rates because they know that there's always going to be a higher volume of traffic coming in. So next is usability. And I think this is sort of a natural progression because you want to use specialized tools that are good at their job, right? But you also don't want to spend a huge amount of time learning a new tool because as developers, we often spend, well, and in operations also, I would never leave out my DevOps friends. We spend a lot of time learning the tools and doing configurations and those sorts of things, right? So just letting data sort of fall into the database would be great, right? But how many of us really trust that that's what's happening? So I think that interacting with our time series data should be easy. I don't want to have to spend weeks and weeks learning the tool just to be able to query it and make sure that everything is going right. So for an example, I'll walk you through how at Influx we sort of handle this problem. So at our heart, we have a database. Influx DB is open source and it's purpose built for time series. Now, when I say purpose built, what I mean is that our engineering team and our CTO built this database for time series, and it's not built on top of any other database. It was handwritten by them. But what happened is we realized that people really love the database, but there were still gaps in this time series problem. One of those was collecting the metrics. So we went ahead and built ourselves an agent for collecting and reporting metrics and events. That's called Telegraph. Also open source, this whole stack is. And it's plugin driven, which means that I could, with one configuration file, set up Telegraph to gather metrics from MongoDB and send them over to my Influx DB instance. Or you could send, from Kafka to Postgres. You don't have to use any other part of the Influx stack with Telegraph because it's plugin driven. Basically, it's just input and output. Influx is not part of the equation. We're just happy to be the people who get to maintain it and make sure that it works. We also have Capacitor, which is a real-time streaming data processing engine, which is a lot of words to say that it's a complicated open source project, but it handles alerting and also data transformations. So if you ever wanted to set up an alert for when I eat too much cake, I don't know why you would want that because you're not the cake police, okay? But if you were, you could get an alert when those cake consumption events hit a certain threshold. That's all easy enough to set up. And then on top of these three things, we have Chronograph, which is sort of the data management platform. It's our UI layer where you could build dashboards and you could explore your data, but you can also configure your alerts and set up users for the database from there. Now, this is super marketing heavy, right? But the reason I'm going through this is to show how modular tools allow for this to be really customizable and to meet specific architecture needs. Because again, if you had to learn from beginning to end, you had to start with Influx DB and work your way all the way up to Chronograph, maybe that would take you a few minutes, maybe it would take you a couple weeks. It's hard to say, right? But you don't have to learn them all because of their modular nature. Influx DB can be used on its own. And it has its own query language called InfluxQL so that you can interact with your data in the context of time, right? One of the questions I get most frequently is why we don't use just SQL. And the answer to that is complicated in many ways, but in my eyes, the reason is just that although SQL is really performant, and obviously good at what it does, we needed to make some considerations for making it easier to work with time, because querying by time in any language can be hard. So we wanted to make it just that much easier. At Influx, we have a sort of core principle of developer happiness, which is just to say that you shouldn't spend a lot of time worrying about configuration and architecture. You should be able to put these where you need them and move on. So next, we're going to talk about specialty. Why do you sort of need this time series database, right? We talked a little bit about how it performs and a little bit about it being usable. But when we get into specialty, we have to think about time series data, because the tools that we use every day can determine how we spend our resources. I use Influx DB every day. And sometimes I have to flip over to the documentation when I'm writing a query, but most of the time I don't. And that for me is an important piece of deciding to use it, right? And most of the developers I know kind of use that learning curve to determine what tools they use, because the time that you spend learning and optimizing tools is time you don't spend doing your job. And if we're talking about DevOps, for example, DevOps is about automation and handing off responsibility. And if we expected you to spend all of your time figuring out how to use our tool, then that would sort of be like the opposite of what I think is at the heart of DevOps. And I also think that we shouldn't forget that time series databases are optimized for time series data, because that means less time for you to spend optimizing the tool. That means that your database can be more efficient and more performant. Something that I heard, I think our CTO say that really stuck with me is that you shouldn't use Influx DB or any of our stack if you say, you want to use it for the sake of using it. You should ask yourself, do I have a time series problem? And if you do, then you look for a time series solution. And that's what I think Influx is. We're very much focused on the solution. What do you need to do with your data? And can we help you do it? That to me is a more valuable question than saying, how can I integrate this tool with my stack because I want to? Because I have done that before many times. I think we're all guilty of that a little, but I can't say that it was the best use of my time. I also just wanted to point out that time series is a really fast growing category, especially in the land of databases, right? Time series data isn't new, but as we sort of see growth in IoT and DevOps, we start to see people who wanting to handle the data more efficiently. And that leads us to kind of this burst in time series growth. So there's an explosion of connected things. Everything in the IoT world is essentially time series data. If it has a sensor, all sensor data is time series data, because they're very much focused on the timestamp. We're also growing because of the adoption of monitoring processes. As DevOps sort of grows in popularity and people realize that they can that they can measure the success or the behavior and competency of their processes, we find that that's best measured over time. There's also a growing need for real-time requirements. And I think as long as I've sort of been in tech, people have been talking about real time. And until recently, there wasn't actually real time, right? It was always off just a little. But now the expectation is that real time is just that. And being able to see that data as it comes in is a really hard problem to solve. But again, this is also clearly a problem that's focused on the timestamp. And anywhere you love that timestamp, it's going to be a time series problem. There's also a lot of just data-driven businesses. More than ever, people want to collect and analyze and visualize data that matters to them. Now, whether that's, the number of traffic on a website, or it's the performance of a database, or it's how much cake you eat, that's up to the business. We don't want to tell you what to monitor because you know your data better than anyone else. You're always going to know what you care about, and we're just going to give you the tools to help you connect with those things. So if we want to talk about some of the areas that time series data and time series databases are being used, there are more than I could probably list, but the ones that I sort of hear about the most often are forecasting. We talked about weather data. It's the perfect example because you want to track data over time, and then you want to use that data to try to make a prediction, right? In weather, we would just call that the forecast. We would just say, well, it's been 70 degrees on the 13th of August in San Francisco for the past 10 years, so it might be again. Or it could be more complex, like predicting stock prices and using that to invest, or machine learning algorithms and figuring out how to train them appropriately. We also mentioned the Internet of Things, all the smart homes and lights and the Skynosaurus, the Skynosaur drones. Anything we can connect to the internet is a really good use case for a time series database. We also care about analytics. We talked about data-driven businesses. We want to be able to track behavior. We want pattern recognition. And the way that we can do those things is through gathering this data over time. And then, of course, the big one is DevOps, where I like to think of time series as a way to measure change over time. And I think that's very close to what DevOps aims to do, is to monitor and adjust for changes. So anytime that you want to monitor or use logging or error reporting, time series can be an important part of this decision pipeline. Now, I've told you generically what people use time series for, but more specifically, I want to talk to you about the influx use cases. Some of our customers use this in ways that we will always find surprising. At Tesla, they use Influx DB at their solar farms. They use it to see whether equipment is running, whether it's not running, or whether those sensors or equipment need maintenance. Because something I didn't know is that all generated energy must be recorded by law. So they have to track where energy was made, who bought it, where it went, and basically its whole pipeline from beginning to end. So one good way for them to do this is to track it through the database. That way they always have a timestamp and a location ID and those sorts of things. When they decided to use Influx DB, it certainly wasn't for lack of options, right? There are a lot of more traditional IoT databases. But in the end, they end up being really expensive. And also, traditionally speaking, they're not as flexible. Influx DB, I think, is what we refer to as schemaless, right? And although I kind of take issue with the fact that a schemaless database is, right, it always has a schema, but it doesn't have a preset one. And I think that this kind of loose structure in the database allows for more innovation. Because again, no one knows their data better than the people making it, right? Tesla knows what they need out of their data better than we do, but we can give them the tools to get it faster. Bbox is one of my favorite use cases, although I'd never heard of them before they were a customer, but they sell energy in rural Africa. Right? Essentially, customers there, they want to pay by consumption, but they don't have a power grid to plug into like many other places. So Bbox makes a battery and a solar panel kit. And then the people who buy those batteries can connect them to their appliances and charge them with their solar panel. And then Influx DB is installed on each one of these batteries. And that way, on Bbox's end, they can track the usage. They can even forecast the end of life so that they can replace the battery before the customer is left with no power. They can also use the data to analyze for patterns. So, for instance, they might know that a customer uses it more at night than they do during the day. They can forecast, roughly how much they use a night, and then they can use that data to say, like, well, if they use it for the next 3 nights, as they have for the past 3 nights or the past 3 months, then we know that they'll be out of battery, or we know that it will cost this much. So they can make smarter decisions because they have the data there to analyze. Comcast is also another interesting use case to me because they're obviously a huge company and they have really interesting needs. So at Comcast, they use InfluxDB to monitor their infrastructure and storage usage. Essentially, they were having a problem where various teams would call in to a manager and say, I am out of disk space, I need more storage. But hardware is expensive, right? So a lot of times they were just running into people who were telling them no. So they introduced InfluxDB to monitor who was using the storage, how much of it they were using, and this provided them a way to justify costs with evidence. So they could call their manager and say, look, here's what I'm using the storage for. You can look at the numbers. I need more of it. And this, I think it's really important to have a way to measure not only what you need, but also what you've done. So this way they could say, you can clearly look at the logs and see, I use this for, I'm sure, very important Comcast things, right? And be able to justify it without having to explain all of your work or necessarily have to make a case, right? Because you have evidence to support instead. Not listed here, one of my favorite open source projects that I've just talked to people about is a whale song project. There's quite a few researchers who I've talked to, and they use InfluxDB to monitor whale song so that they can track pod behavior out in the Pacific. I can't claim to understand a lot about whales other than I think they're pretty cool. But I like the academic use cases because in academia, you really need open source tools because funding is hard to come by. And when you're in the land of open source tools, it can be tough to make decisions because you really need reliable software. And as someone who spent a long time in academia, I'm really happy to be able to contribute back to that particular part of the world and say we have, reliable and I think interesting software that you can have for free. I feel like maybe I didn't mention that enough earlier. That whole stack I showed you from Telegraph, Capacitor, Influx DB, and Chronograph are all open source. So now you're probably asking, what should I do? I mean, now you definitely know why you need a time series database, right? Because if you have time series data, then we definitely have a time series solution for you. You can download Influx DB and all of its friends from our website or from our GitHub. And you can get nightly versions that feature some of our newest betas. Like we have a new query language coming out called Flux. And I think it's really innovative and interesting. And if you're someone who likes to play around with new tech, I think you'll find it super engaging. We also focus on something at Influx that our CTO likes to call time to awesome, which means, again, along the lines of developer happiness, it shouldn't take you more than 5 minutes to download and install these. If you're on a Mac, you can just use Homebrew. We also have a community site. And here is where you can ask technical questions. You can read other people's questions and learn about how they're using it or why they chose it. And we also have a series of time series meetups all over the US. We have one in San Francisco, Denver, New York. We're starting one in Austin. We have one in Boston. And soon we'll have one in Minneapolis and Chicago as well. So I'd be happy to answer questions about all of those things. But again, you can always go onto our community site. I'm there along with the rest of our developer relations team and some of our engineers answering questions as best we can. So now I think we're going to enter the Q&A portion.
Yeah. So I want to remind the audience, if you have a question for Katie, just use your GoToWebinar control panel, submit your questions, and we'll get to them as soon as we get them. But we do have a couple to start with. So the first question is, can I contribute to any of these projects?
Oh, yes. That's a great question. So because we love open source and we love all of you, all you have to do is go to our GitHub, find the project that you feel like you want to contribute to, and clone it, do your work, and submit us a PR. We get most of our open source contributors on Telegraph because, again, it's plugin driven. So if you find yourself in a position where you want to use Telegraph, but there's no plugin for the service that you like, you can write that plugin and we will get it approved as part of our stack. We would love to have you as a contributor.
Awesome. Okay. Next question. How is this different than Elastic?
Yeah, also a good question. This is a question I get a lot of times at trade shows and conferences and things. I think for me, this always kind of goes back to this like specialty tool question, because Elastic is also a specialty tool. Elastic is really great at what it does, which is text-based search. And we're really good at what we do, which is time series data. There is some overlap, obviously, but I think if you have to ask yourself about your priorities. If you care more about text search than anything else, then maybe Elastic is the right choice for you. But if you think you need the timestamp more, or you care more about that precision time down to the nanosecond, then maybe time series database or Influx is for you. But often we see people doing both because it's hard to decide. And if you can get Influx DB for free and add it on to like enhance your Elastic stack, then why not, right? So we do see a lot of people using both and using Influx to just enhance the data they have available for Elastic.
All right, great. Next question. Can I use Telegraph with a different database?
Yeah, of course. Telegraph, again, is completely plugin driven. So we have over 140 plugins for Telegraph, and I think probably only 8 of them were written by anyone at Influx. So we have plugins. I've used the ones for Postgres and MySQL and MongoDB, but there are some for more databases than I could probably list. But I know there's Maria and Cockroach and Cassandra. I like this idea of modular software. I like to think that I like my software like I like my code, which is in these easy digestible chunks, right? So Telegraph gives you a good way to just serve as a pipeline for data without having to worry necessarily about what's on either end. As long as there's a plugin for it, you can get the input and output as needed.
All right, great. The next question, can I build Influx DB clusters?
So, excellent question. In the open source, you are limited to a single node. The clustered version is our enterprise version. So this was a decision the company made early on because in the world of open source, it can be tough to decide how you're going to make money. But Influx Enterprise is our high availability clustered solution. That is what was being used by those use cases at Tesla and Comcast that I showed you earlier. And although I know that in the open source community, it can be a little bit of a tough spot to say, like, this is where it stops being free. I do think that we have a ton of people who start out with the open source, use it, and either use it as a proof of concept, or they just use it for years and love it enough that they upgrade to enterprise. So the clustered version is Influx Enterprise. We also have Influx Cloud, which is sort of the hosted enterprise version. But yeah, so single node on the open source is your only limitation, and then clustered is enterprise.
Okay, great. Next question, do you have performance metric data in comparison with DynamoDB, MongoDB, Redis, etc.?
So I think that there are benchmarks on our website. I couldn't quote you any of the numbers, but if you go to influxdata.com, there is a section devoted to benchmarks that are done by a third party, and you can sort of do a comparison. There's also a fair number of Stack Overflow and Reddit threads about it.
All right, great. Okay, next question. We've gotten some really great questions in, I got to tell you. Okay, next question. What are the advantages of Influx DB over Prometheus? Is Influx DB easy to manage with Spring Boot framework like Prometheus?
Yeah, also excellent question. So usually we don't do a direct comparison with Prometheus because we do a couple things differently. Prometheus doesn't offer long-term store, and we do, right? So we are actually the official long-term store for Prometheus. You will find us as a partner at all of their conferences, and we fit easily and into any of the same stacks as Prometheus. Prometheus has a built-in influx support and vice versa. So we're always going to fit wherever Prometheus fits.
All right, great. This next question, I get a little chuckle out of it whenever I read it. I just okay, I'm just going to dive right in. Does Telegraph have a plugin for monitoring Android phone usage? In other words, can I use Telegraph to monitor which applications my teenage daughter uses and for how long on her Android mobile? You can understand why I'm chuckling.
I like where this person's head is at. I like what you have going on. So because there are so many plugins for Telegraph, the short answer is I don't know. But you can go to the GitHub repo for Telegraph or to the Influx data docs and get a full list of all of the plugins available.
All right.
That's where I would start.
Right. All right. The next question, is there a Jenkins plugin to send data to Influx DB?
I think so. Again, I think the answer is you would have to go check the full list, but I am like 75% sure that there is a Jenkins plugin because we are often used in that CI/CD pipeline, and internally our support team uses it also. So I'm pretty sure there is.
It would make sense then. Yeah. Okay. All right. Great. So the next question, how easy is it to plug in the data generated from various sources to the Influx DB, such as networking data generated in Kubernetes setup, for example?
Yeah. I'm gonna say real easy, because we pride ourselves on that, right? So not only do we can natively sit on a Kubernetes cluster, for example, like depending on your setup, an instance of Influx could live on every node or on a single node that was collecting metrics from the rest of the cluster, and this would all either use an agent of your choosing or Telegraph. And Telegraph has some really great plugins, especially for network metrics. So Influx DB does have a native data protocol, which is called line protocol. But a lot of the Telegraph plugins will tell you, you'll be able to set the data format and tell it, is it already in line protocol or is it in JSON or is it a syslog? You'll be able to set the format, and then on top of that, outside of a Kubernetes style environment, we also have just a straight API you could hit, so that anywhere you could like curl or write an API request, you can hit the database. And then we have client libraries in dozens of languages. So we try to make it as easy as possible for you to put data in the database.
Awesome, awesome. Okay, next question. Can Influx be used for application log storage and analysis?
So one of our most recent additions is logs, which is very exciting. Right now, we have an rsyslog Telegraph plugin that you can configure, and then you can view those logs in Chronograph. Now, the analysis portion is kind of the trickier bit. Like you can view the logs, and I'm trying to think about like if the tools don't do the analysis for you, I guess is what I would say. But you have the ability to view the logs, and then using the data from the logs, you could then view that time window in your data to figure out some like correlations.
Okay. Excellent. Next question. Sorry if already asked. Is the query language extensible with Python libraries, and specifically Python R libraries for analytics?
Yeah, good question. So the easiest answer, if you were using Python, you could use the Python client library so that you didn't necessarily have to write Influx QL specifically. But if you did, then you could just use the API. If at any point you were like, this is too complicated, yeah, then you could just use the API to write the data and read the data and circumvent it completely. But we do have libraries for Python, and I'm pretty sure we have one specifically for some of the data, the specific Python data libraries also.
Okay. All right. Great. Well, I'm amazed at the quality of these questions. They're so good. The next question, can you please share with us how Influx DB internal architecture looks like? Is it in memory, how it works fast, or super speed?
Yeah, I know that I'm not allowed to say magic, but magic. No, so
Leprechaun. Oh,
there's a few reasons that the database is so good at what it does. First of all, it has a really excellent compression algorithm. So when those compactions happen, it doesn't end up taking up a lot of space, and that's one important piece. It's also columnar storage, if you're familiar with that idea. And we've written our own um, time series sort of engine, I guess you could say. Um, Again, no part of our database is really based on anything else. So I would say to you, you could read some of the documentation on the TSM, which is sort of the inner engine that handles the data. And also you can read up on TSI, which to address the question of whether it's stored in memory or on disk, TSI is a way to allow for in-memory or on-disk storage, depending on what's going to be fastest. So TSI is a feature you can enable or disable, and it works especially well for high cardinality situations where the data is complex enough that it's slowing down the queries. And when with TSI enabled, you could see a huge improvement if you have complexity that was like approaching, in the millions or billions, or not in the billions. That'd be crazy. Don't be crazy. But in the very high millions, then you would see a dramatic improvement. And we have quite a few white papers on that are also on our website if you want to just read about the storage engine and how it works. But essentially, it's because of columnar storage and the underlying engine and the compression algorithms.
all right. Excellent. Okay, next question. Can you tell me more about Flux? Can I use it on the open source version?
Yeah, of course. Flux, you can download in the nightly version of downloads on our website. And we built Flux to start to improve our query language. Influx QL works really well, but we wanted to actually get a little farther away from SQL because for all the reasons we talked about, time series data is significantly different than other types of data. And we think that in order to be really accurate in the way that we query and also easier to read and understand, that it kind of called for a new language to query with. And as the team built this new language, its usability and potential to become something more than that became obvious. So Flux started out as a query language, but now is taking on a new life as a full-blown programming language. You can get it in the nightly, and there's a really decent README in the docs. In the repo on the README, and you can kind of get a feel for what it would be like. We're still taking feedback too, so if you are using it and experiencing some interesting or complicated issues, you can go onto our community site. There's a Flux section where people are having discussions about sort of how it's doing.
All right. Great. Well, that is pretty much all the questions that we have. So I'm going to go ahead and close out the Q&A period. So thank you to everybody who did submit questions. I have to tell you, I'm very impressed by the quality of the questions that came in. They were awesome. So thank you all for taking part in that respect. I also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or you just want to listen to it again, you will be able to access the webinar on demand. As I said before, we're going to be sending out an email after the webinar that will include a link to take you to the webinar on demand. The webinar is also going to be living on the devops.com website. So if you want to just check it out there on the site, that's cool too. Just go to the webinars tab, click on demand, and it should be right there waiting for you. While you're there, go ahead and check out the other webinars that we have both upcoming and on demand. Hopefully there'll be something there that you find interesting. Katie, Cater Tot, thank you so much for
You're welcome.
giving such a great presentation, and I enjoyed the the cake chart, especially. So now I'm hungry. I want to go get some lunch. Um, so thank you for joining, and I am Charlene O'Hanlon signing off. Have a great day, everybody.